Alright, fellow calculars, this is Samantha, and I'm doing my week number 6 video. Excuse me if I've chosen a couple of easy ones. I've had a rough week at work and haven't really had any time to really dedicate to calc on any sort of significant basis, so I'm giving it a go with what I've got to do. So I chose number 10 because I kind of thought maybe you could solve this in a couple of different ways. But the way that I approached this and ended up getting the right answer, and maybe I was wrong in how I did this, maybe somebody will chime in, is, well, the original question was, does a sub n equal to the square root of 6n over n plus 1 converge? So how I approached this is I took out what was inside of the square root sign, and I worked with that to begin with. And what I got is that the limit as n goes to infinity would be 6 times infinity over infinity plus 1, which is really just infinity over infinity, which is an indeterminate form, and we thus must apply L'Hopital's rule. So the first thing that I did was I took the derivative of 6n, which gives us just 6, and then I took the derivative of n plus 1, which is just 1, and I got 6 over 1, or simply 6. And then I just put that back into the square root sign, and I got 6 over 1, or the square root of 6, and that would then converge. Square root of 6 was the actual correct answer to this problem. I am not sure if you can simply take what's sort of inside the square root out and solve that and then kind of put it back in. I know that we could also write this as 6n over n plus 1 to the 1/2, which would be the same thing as the square root. So I guess you could solve what's in here and do the same thing and then just raise it to the 1/2 power. But again, I did arrive at the right answer, but I'm not sure if how I did it is actually legitimate. So I do hope that one of you fellow calculars will comment on this. The next question that I chose to do was number 12. Does a sub n equal to L of n, or the log of n plus 1 over the square root of n converge? Excuse me. So I rewrote this as this natural log of n plus 1 over n to the 1/2. When I plug in the limit as n goes to infinity, we have the natural log of infinity over infinity to the 1/2 power. So as you see here, the natural log of infinity stays the same. There's nothing that can really be done to that. But infinity raised to the 1/2 power is actually still infinity. And we have in Theorem 5, that goes over some commonly occurring limits, we have the limit as n goes to infinity for the natural log of n over n equal to 0. And so this does converge, and it does so at 0. Alright, calculars, I hope that everybody has a good week, and I look forward to seeing the rest of your videos and your comments on my video.